Hi, and welcome to a guide to completing the CXC Mathematics SBA. Today we'll be looking at the method of data collection. In particular, we'll be looking at non-statistical studies. Let me first start by putting the word non-statistical within context. In this presentation, the term non-statistical does not mean qualitative. Rather, it refers to all other strands of the CXC curriculum that excludes statistics. Let us first look at the variable identification. The variable identification in non-statistical studies could pose a challenge. So let us look at identifying the variables in the non-statistical studies. Let us first look at consumer arithmetic. Suppose you were studying the cost of tiling your kitchen floor. Then the following could be variables: the cost of the tile, the tile size, the tile texture, whether the tile is indoor or outdoor tiles, or whether it is glazed or not glazed. Recall that a variable is any feature or characteristic that changes within the study. For an SBA involving trigonometry, then your variables can be the angle formed, the angle of elevation obtained, the angle of depression, or it can be the bearing. For geometry, the variables could be the space an object occupies, its shape, or its dimension. It can also be the volume of a container, its shape, or its dimensions. It can also be the number of objects occupying a space. For linear programming, the variables can be the quantity of commodities involved, the amount of space occupied by a commodity, or it can be the amount of storage time utilized for housing a commodity. All the aforementioned strands would be explored throughout the duration of this presentation. But before you move on, kindly hit that like and subscribe button and put on your notification bell so that you will be notified of future uploads. Let us now turn our attention to the types of sampling, starting from convenience sampling. Looking at the consumer arithmetic scenario, then convenience sampling can mean the selection of the tile samples from a convenient hardware store, whereas for geometry, convenience sampling may mean the standard measurements that are available. For trigonometry, convenient sampling may mean the selection of angles that can be easily measured because of the availability of your measuring instrument. For linear programming, however, convenient sampling can mean the selection of respondents that may be conveniently obtained, or observations made at a convenient location. Remember, these respondents or observations made are critical to determine the constraints such as pricing, rates of stock turns, etc. Looking now at cluster sampling, for consumer arithmetic, cluster sampling would mean the selection of samples within a particular geographical location. For geometry, cluster sampling would mean samples drawn from a collection of lines, shapes, and solids that are of the same family. Example, parallel lines, quadrilaterals, cones, as the case may be. For trigonometry, cluster sampling would be samples that may be drawn from a particular family. For example, the family of acute angles. For linear programming, cluster sampling may be the selection of respondents that may be of a specific industry. for example, the hotel industry or the agriculture industry. Looking at random sampling, for consumer arithmetic, random sampling may mean the random selection of tiles from a randomly chosen hardware, but they must bear the same or similar characteristics. For example, you may be interested in porcelain tiles only. For geometry, however, random sampling may mean the random selection of samples that are both standardized and non-standardized. For trigonometry, random sampling can mean the random selection of angles, whether they are easily measured or not. Random sampling for linear programming can mean the random selection of respondents or observations made from a variety of industries. Let us look at sample size within the context of the strands we previously mentioned. Sample size from a consumer arithmetic point of view means the number of tiles that were examined. For geometry, it would be the number of lines, shapes, and solids that were examined. For trigonometry, it would be the number of angular measurements that was taken. And for linear programming, sample size would mean the number of respondents or observations made. Here is a rule of thumb. If the number of the population is greater than 100, then use 100 as the sample size. However, if the population is less than 100, use the entire population. As mentioned in a previous video, data may be classified as either being primary or secondary. The primary data are data that you, the researcher, collected, whereas secondary data are data that are collected by someone else besides the researcher. For example, if you were to call the hardware store to ask them the prices of tiles, then that would be secondary data, because they would have compiled the price and given it to you. However, if you were to go to the hardware store and you would have seen the prices yourself and recorded it, that would be primary data. These two types of data are further classified as being numerical or categorical. That is to say, primary data can be divided as being numerical and categorical, and the secondary data can also be classified as numerical and categorical data. Numerical data is further classified into discrete and continuous, and the categorical data is further subdivided into nominal and ordinal data. These were discussed in a previous video. Finally, we will briefly look at some data collecting instruments. Some of the data collecting instruments include interviews, surveys, and questionnaires. We will be looking at these and other data collecting instruments in greater details in the next video. See you in the next video, and please don't forget to like, share, and subscribe, and hit that notification bell so that you can be aware of future uploads.